So what we'll do is I'll just start the presentation now, and then we'll just kind of roll into it. So welcome everyone to the February 9th edition of the Building Operators Association of Calgary's monthly meeting. And in today's meeting, I'll get to introduce the players in a minute here, but so this one's going to be a little bit different, which is all good. And before we get into that, and I'll introduce the topic, just want to talk about a few things that we're contemplating on doing here with our Zoom meetings. And so we're thinking about putting a series of meetings together in conjunction with Brian Stringer, and where we were talking about, you know, some HVAC stuff, and we're sort of looking at putting on one about economizers and things like that. That's kind of relevant for a cold day like today, and topics like that that are sort of relevant to building operations. And then we're thinking of maybe doing one other one other than our monthly meeting webinar, and then that way we can you know, cover a wider some wider topics. And in fact, if anyone out there has got some good ideas on for presentations or little talks like that, where you have some interest, some expertise, let us know, Les or myself, and we'll see what we can put together. In the days of COVID here, there's really no rules, so we're just looking for different and interesting things, sort of like what's going to be coming up here in a minute. And of course, Brian Stringer is also you know, good at the putting little things together. Next month's webinar and is going to be put together by Kyle Diagit. I can never pronounce his last name.
D'Angelo?
D'Agostino? I don't know. Anyway, sorry, Kyle. Anyway, we talk about heat exchangers, which might be interesting. Maybe we'll have to get these two guys together. There's a lot that can be done. So again, if anybody's got any presentations or ideas for ones, you know, some other things that we could probably talk about is, you know, power grid stuff, or cogen, or really the sky's the limit on what's of kind of an interest. We probably will be touching back from time to time on some COVID stuff as it becomes relevant, more on sanitation and things like that. But anyway, we'll kind of see how it goes, and see what you folks would like to see. Now, to see our webinars, you can just go on to YouTube. Well, you'll be able to see it. We'll announce it for the Zoom thing, but if you miss them, then they're recorded on YouTube, and it's under Building Operator Association of Canada, and you just type that in on the search thing, and then it'll bring up our presentation. So, and that goes right back to September. So anyway, we'll try to keep it rolling. Sometime this June, you know, that's when we get into election times and stuff like that. Or we're always looking for more people to participate in our executive, and you know, new ideas and new stuff is always welcome. And so we'll probably be talking a little bit more about the executive structure towards the end of this quarter, I guess you'd call it for us, be around June. But we have a long ways to go to get to there, and then hopefully, who knows, maybe sometime this year we can actually have a meeting. It's who knows. So I guess we might as well get into the presentation here. So the topic of our presentation is alternative waste management technology to produce biomass energy. And so today we have a local company that's Eco Growth Environmental, and they utilize an innovative process to turn organic and cardboard paper waste into biomass feedstock. Thereby diverting this type of waste from traditional landfills. And this presentation, which is going to be a little bit different because it's going to be kind of a live and in color kind of where they're going to show us the actual process and their application. This presentation will provide an example of how biomass waste conversion process can be used to provide an alternative fuel source, and they're going to show the example where it's utilized by MAT to produce environmentally responsible energy, which is required to support their cleaning process. So it's something quite different and very interesting. And so our guest speaker for this presentation is going to be Glen Smith. And Glen is the VP of Eco Growth Environmental. And our guest panelists, you'll see one will be Kim Caron, who's the president of Executive MAT Group of Companies, and Mike Thompson with Clean Power Worldwide. And then what we'll do is you'll be seeing Kim a little bit during the presentation, and then towards the end, before the question and answer period, Michael explained how Clean Power Worldwide interacts with this technology and what their place in this is. And so if I can ask you then, any participants out there to just write your questions in on the question and answer thing. I'll watch for that, and then I'll present your questions towards the end of the presentation, or if it fits in during, I'll do whatever kind of works, and then hopefully then we'll kick off certainly a different presentation than what we've done in the past. This will be more like our building tours that we used to have that, of course, nobody can do right now. So with that, Glen's just gonna kick it off by describing his process, and then Mike will tie it up at the end, and then we'll do the quick Q&A. So boys, might as well kick it off, Glen, and
okay,
see what happens.
Okay. Again, my name is Glen Smith. I'm the Vice President of Eco Growth Environmental here in Calgary. We operate out of Kim Caron's Executive MAT group of companies. So we're an industrial laundry here in Calgary that has about 60,000 square feet of space, and we wash things for a living. So we wash about 100,000 pounds a day of entrance matting for clients all over Canada. We have multiple branches that do that. In the last 10 years, we've been, I guess since Kim started Executive MAT in 1992, we've been looking for alternative ways to use our waste stream and turn it into energy sources. And what you'll see here is kind of what we have up until date, up to this date, but we're turning all our available waste streams, and we have for quite some time, into usable energy, because we heat on a daily basis about 13,000 gallons of water for our industrial laundry. And we used to use natural gas mostly to heat that stuff. So we thought when the carbon tax come in, when landfill diversion comes in, when the right thing to do with waste come in, Kim began understanding how to best utilize it and turn it into a carbon neutral fuel source instead of a cost to get rid of it through our dumpsters. And in 2013, we started a project with the town of Cochrane where we diverted their waste paper towel from their dumpsters. We had sold them their their paper products. We took it back from them at no charge. And we found out during this pilot that 70% of the volume that was inside of their dumpsters was bags of paper towel. And we just found out that almost every other building in the world, 30 to 70% of most volume in most dumpsters and buildings is paper towel. And we just started diverting that while we're there changing the mats. So once every week, every 2 weeks, every month, we'll remove the paper towel for free. We sell them the paper goods in, and then we take it back and divert it from our client's waste stream. And we turn it into energy that heats the water in our laundry process. So during the process, we diverted it from their landfill, we diverted it from their dumpster. And then we began understanding when we divert the material, it doesn't go to landfill, it doesn't get buried in landfill, and it doesn't turn to methane in landfill. So there's an offset credit we were creating with that, besides the efficiency we were creating with just the removal from their dumpster. And during the 1 year pilot process, they purchased about $3,000 worth of consumable paper towel, those type things off of us, but we saved them about $3,600 a year in their tipping fees because we diverted that volume away from their dumpster. So Kim is using, we have a process inside our laundry where we take hazardous hydrocarbons out of printer towels. We do this for most printing companies across Canada. And we used to do that just out of cloth rags. And then when the print industry went to more of a consumable paper type product, we could do the same thing. We take hydrocarbon out. We do something with that. Kim won the Emerald Award for that here in Alberta for this technology in 2012, but he's been doing it since 2002. He just doesn't let the effluent from the rags go down the drain. So we just developed this process where we remove the hydrocarbons, take them out of a cloth, and then now we take them out of paper printer towels, but we were left with a mountain of paper we didn't know what to do with. So we got into gasification technology about 8 years ago now, and we've been utilizing it ever since. And we started with just the paper waste. And then we began saying, okay, well, how about paper towel? How about paper cups? How about paper plates? How about our dryer lint? Everything that is available biomass feedstock that's in every dumpster around the world is a carbon neutral fuel source that can be used on site. So this that we're in is called our energy recovery container. And this sits alongside of our industrial laundry, and this heats our laundry water. But our garbage, instead of going to the dumpster, which is on the other side of this container, comes in here. So our waste cardboard, our waste wood, our paper towel waste, our printer towel waste, everything comes in here, and we benefit it from the energy that's produced. We save about $60,000 a year in our natural gas costs because we're using an already free biomass fuel source, but we're also not having to pay to get rid of it. And that Kim doesn't like paying to get rid of anything. So we just turned it all into energy instead. So every ton of material we divert, we actually offset about 8.5 tons of CO2 equivalent So at today's carbon pricing, which is $30 a metric ton, we are creating offsets upward $400 a day in offset credits just on today's carbon pricing. And this is derived from an already biomass free fuel source that is in our dumpsters currently. There's no market for cardboard right now. That's the perfect feedstock for our gasification boiler. And then food waste. A couple things, we have to prep food waste. Like we can't just combust it in our gasifier. We actually dehydrate it first. So we build, since we're laundry guys, we build gasification or organics dryers. So we put all the organic waste from a building or even our facility into this unit. And it's a 24-hour process where if 1,000 pounds goes into this machine, the next day you'll have about 200 pounds of dry fiber-like powder at the end, which is sterilized, and all the water weight, which is 80%, is gone. So that finished material that Kim's holding doesn't smell, it doesn't continue to decompose, and you can get rid of 80% of the weight and the volume by just dehydrating it. That was a win for our clients right off the start. And now, instead of having 10 recycle bins on wheels lined up every day being removed for food waste, now we go to a place, that same place with our dehydrating unit, and go there once a month and pick up like almost a pallet-sized tote instead of having 10 bins a day removed. So there was a cost savings from our client's point of view, and there was also a more opportune time to pick it up. So we could match it to where we had our mat service do it at the same time when we're there. So we just got really efficient in how we dealt with the waste stream that we know everybody else has, because we have the same stuff here in Calgary. And I'll let Kim chat a little bit because I get carried away. And
Sure, well, why don't we show everybody?
Sure. So we didn't want to have a boring old PowerPoint today. So what we're going to do is explain to you how we scrub energy out.
So I'm sitting in front of a 300,000 BTU per hour hot water appliance. So this machine here is creating hot thermal energy for the laundry on the other side of the building here. And this building we're in is a purpose-built system, R40 rated walls. So it's 30 below outside right now, and I'm in here in a t-shirt. So very, very efficient. What we have here is we have an electrical connection to electric panel on the wall. So that's the single electrical input. And we have a glycol line coming in. So it's basically a cold line coming in and a hot line going out. And you can see here we have a plate heat exchanger. So the glycol comes in, passes over the heat exchanger, and leaves the building hot. The system here is certified with Alberta Environment to run on organic type materials. So anything that derives from a plant or an animal. One of the big challenges with any kind of appliance like this is particulate matter. And so we have a particulate knockdown technology built right in. It's very, very, when it runs, you don't really see anything coming out of the stack other than some water vapor every now and then. So this is the system. We have an automated ash cleanup. So it cleans itself automatically. So basically we're a ton, this system will take roughly half a ton of material a day, and we're left with 1.5 to 2% ash at the end. So this is the feed Clopper. So this is where the biomass material is stored, and it's like your fuel tank on a car or whatever. So it's being fed to the system via an auger down below. And this is the auger here. The system is controlled with an aquastat. So when it reaches temperature, it shuts itself down.
We planned that.
So it won't overheat. And it's a vented system, so it's non-pressurized. So you don't have to worry about traditional boiler type things. So now the feedstock for this, this could be any type of material. It could be wood pellets, typically is what people think of for biomass. But what we've done is we've chosen to divert landfill waste and convert that into the biomass feedstock. And so what we're doing here, this is a dry shredder. So we can take things like paper cups, you name it, throw it in. And it's as simple as this. Turn the machine on, turn the conveyor on, and now it'll be feeding the system. So pretty basic technology here. This, if you're doing cardboard, you can do 300 to 400 pounds of cardboard an hour. So if you've got a large supply of cardboard, you come in, you spend an hour or so in preparing your feedstock. This machine here is our food waste dehydrator. So your wet food waste comes in on this side. Within typically it's a 12 to 16-hour process. It works its way to the other side, becomes fully dehydrated and size reduced, and then this gets fed right to the boiler as well. So pretty simple. What's interesting about dehydrated food waste, it actually has more BTU value per pound than wood does. And that's a function of the oils and whatnot that are inherent in things like and whatnot. So this basically is what you would see in a remote camp, for instance. A lot of our clients just have the dehydrator, and they don't make enough biomass to run their own boiler. So we offer a service where we'll pick up the biomass periodically, and because there's no odor and it's basically sterile, you could stockpile this for a year or more. You won't have any rodent issues or flies and whatnot. We have one of these systems in a penitentiary here in Alberta. They went from a twice a week organic service, a removal service, and they went a year and a half before they removed the dehydrated material. We picked it up and used it as fuel here in the plant. So pretty basic. This technology can also be used to prepare things like plastics for additional uses. To use plastics as a feedstock in dimensional lumber, for instance, has to be shredded and dehydrated before you can use it. And so this technology fits well with that as well. So I think that's pretty much the system.
So when we found out this by mistake, when we started dehydrating food waste, we literally went to King's Restaurant, which is just down the block from us. And we picked up 200 pounds of their war wonton, brought it back here. There was tin cans and everything in it. There was aluminum foil and a lot of wet broth and noodles. And we said, okay, we built our first small dehydrator, which is the size of a small freezer. And we put in 200 pounds of this waste in, and it was about, I don't know, about 4:30 in the afternoon. We had made this stainless steel dryer for organics. We didn't even know if it was going to work. And we actually put this material in. We went home, not knowing what was really going to happen. Should we babysit it all night or what? But when we came in the morning and we only seen about 30 or 40 pounds of this dry material, we said, holy, that's a huge reduction. There was just a little bit left. And we thought, well, that makes sense to do that just for that reason. And they said, okay, well, let's try something else. And then, so over the last I guess 7 years now, we've been trying different feedstocks. And I know less is in the wastewater business, but here we go. This is human biosol that's been dehydrated with sawdust. So we sterilize it. But guess what? This has a really good BTU value. So it's almost similar to wood. So my next presentation, we're just going to get a toilet seat and we're just going to, I mean, we can do a lot of different things with the technology, but we just have to dehydrate it into a usable fuel source. So to do this at a northern camp or even in future buildings, I think you could possibly design out infrastructure like sewers and stuff like that and have all your waste from your building, all your waste water, and you just turn it into a usable fuel source for a building. And to really start to think outside the box of what you can do with the wastes that are leaving our building, whether it's underground or through garbage trucks or through organics trucks, there's a huge opportunity to generate carbon credits from this stuff, which is a carbon neutral fuel source. Everybody's got it. So having this as an available feedstock that you're currently paying to get rid of in some form or another, this is a great opportunity to get involved to lower your carbon footprint for your clientele.
We have a briquette making machine inside the plant. This actually is a flax stubble briquette. And in Canada, we burn openly in the fields about 1 million tons a year of this. This actually makes an ideal fuel source, fuel material. So not only are we committed to global warming and pollution with the flax burning, but potentially it could be a huge energy source, particularly for Saskatchewan and Alberta. So where this technology can be applied is a huge number of different applications, and agricultural waste obviously is just one of them.
If you like, I do have, there's a couple of questions here we can kind of weave into this as we go. If you,
For sure, yeah.
this is the right time. Just going to take them here one at a time. And so Jacques Robert is asking, what is the energy use offset to produce the food and paper waste? So energy use offset.
So we call that the energy balance, energy in versus energy out. This appliance here runs electrically. We have a radiant heat and a forced air system here. And it consumes about 30% of the energy potential of it. So we call that a 70% efficiency. The boiler operates with a simple 110. There's literally zero electrical input on the boiler itself.
Okay, so maybe we'll just someone that's
and just to further that, on our emails, we actually have an energy balance flipbook that's attached to every email we send. So you can go into every appliance that we make and you'll see the energy balance.
Oh, okay. So next from Anonymous, this is so cool. What items could you not put in this unit? And he's saying, i.e. plastic, but probably this question came up probably just before we started talking about plastic, but what are the limitations on, I guess, is what the question is.
So obviously inert materials, there's no value, glass, metals, there's no value putting those through the system. Plastics will go through the system just fine. As a matter of fact, it actually improves the BTU value of the feedstock. But from an emission standpoint, we're not certified to run plastics.
Okay, so all right, then from an emissions point of view, then you're not certified for plastic. So is that just to expand upon that, there's probably some place where you can take that with scrubbers and stuff like that, I'm assuming, but
you know,
it's economy of scale, I suppose,
Well, Well, one of the projects we're doing with SAIT is they are actually doing emission testing after we have a scrubber on the inside power plant. It's a hydronic scrubber. And that's one of the things we'll be testing is different feedstocks and what the scrubber does. So there's no data that you can look up on scrubbing plastic emissions through a hydronic scrubber. So we're going to actually run the test ourselves through SAIT.
Okay, well, that's good to hear that you're getting some participation from folks like that. That's good.
Mhm.
Let's see what else we got here. Oh, Jacques again. As a waste producer, are there incentives to sell your waste from buildings to the locations which house the devices for the use in energy generation? There you go, cogen. So this,
Right. So you could have, if you had a large thermal load, you may have the boiler system, but not enough feedstock to feed it. So you would be relying on somebody like ourselves for logistics to move dehydrated food waste or paper and cardboard from one site to another. So is there a market for the biomass? There is, but it's not well developed. Right now, basically what we do is we take everything that's being produced and we run it ourselves through our own plant. So we haven't exceeded our own energy needs at this point.
yeah, I suppose sort of to expand upon that a little bit, there's probably, on the cogen side, anytime that you're producing energy on a boiler, there's an opportunity for cogen, where you can produce electricity or anything else. So
The electrical production, we're not there yet, and the technology really isn't there. It's not very efficient. It's quite expensive. So right now we're producing just the thermal energy. So,
yeah.
But one of the things, getting back to Jacques' question, is we have a pellet mill inside the plant as well, and by producing pellets, we can actually pump this biomass. So we can actually deliver pellets via truck and pump, and have these systems set up all over the place. So the city pools or whatever, we can actually start a business doing that.
Oh, I see what you mean. So
the stuff we're focused on is the refuse derived biomass. In the industry, when people think of biomass, it is wood pellets, wood waste, stuff like that. In the world, the worldwide output of biomass right now, let's take Japan, for instance. Japan's going away from coal, and Japan's going away from nuclear, and they're going wholeheartedly into biomass. So the biomass that they're going to need come 2022 is about 60 million tons a year themselves. Now, they're currently looking for biomass sources to derive it from. Now, the worldwide output of biomass, 70% of it, guess what, comes from Canada, in particular, the two western provinces in Canada. And this is where all our wood pellets are made, and then it gets put on container ships in Prince Rupert, and it sails through the Panama Canal over to the European countries, and they wave the green flag because they're using alternative energy in place of a fossil fuel. And this is what it is. So what we're focused on is not trees. We're focused on the end of life product that is already in our dumpster, which is everything that we're making is almost like a wood-like fiber. And we just produce energy out of what's already available in our dumpsters. So we're just skipping that step. So biomass on the worldwide market, if you were to pelletize it and get it on a container ship, is worth almost $200 a metric ton. So when you guys start calculating what comes from waste from your buildings and potentially thinking about, okay, well, I have 10 tons a month leaving my building in the form of cardboard, dried food waste. Yeah, at some point we're going to be able to monetize that. but it's still the logistics to get it to where it needs to go. So our idea was to deal with the waste on site with a micro system, utilize all your own energy first. And if you have excess at that point, there'd probably be a market within probably the next 10 years for that finished material. So yes, I think you will be able to monetize our waste streams based on what we're doing here. And you'll see more of this going forward in the future. We're just, I tease Kim all the time because Kim was one of these guys who paid for curbside recycling 25 years ago, right? So he just brought his mentality, that same mentality, into all the businesses he runs to take care of the waste properly and efficiently, and learn how to monetize it and learn how to get the best benefit and carbon reduction out of it. So this is what we've learned. This isn't an overnight thing. Kim's been doing this for like 26 years now. So it's been a work in progress for quite some time now, since 1996.
Okay, well.
So the economic driver for this technology is really trucking waste away from a building. So we're eliminating the amount of trucking, particularly good waste, which is 80% water. But with the new carbon tax and the emission issues, we're driving a whole new economic model. And the reason is, food waste, when it hits landfill, we bury it, creates an anaerobic condition, which creates methane gas, which is extremely potent greenhouse gas. But more importantly, the emission stream is considered carbon neutral because of the type of feedstock. So when we offset using natural gas, like we do here in the plant, the actual carbon intensity reduction is worth more than the energy itself. So it's a really interesting dynamic that's happened in the last, 3-4 years. And we were doing this prior carbon tax initiative.
Okay, so yeah, so the carbon tax, I can see where that plays into it. Well, we got some more questions here. Kevin Delahunt, how long does it take to dehydrate the food in your system?
So that's a function of how much moisture is in the material. So obviously, the lower the moisture content, the quicker the cycle. But in this particular unit, it'll handle 1,000 pounds or half a ton a day. And it can be anywhere from 12 to 18 hours from start to finish.
And I'm assuming that would be kind of scalable to whatever application, the site had or whatever. Right?
Yeah, our largest system is a 1 ton per day. So we have a 200 pound, 1,000 pound, and a 2,000 pound.
But our plans are, like, as we grow and as we get larger, like our largest, what we call tub, is 24 inches in diameter and about 12 feet long in our largest unit. So once we get to the point where we want to make a diameter the same size as this container, it'll just accommodate way more volume. So you could, instead of dumping it in by hand, we can have a dump truck dumping into it. And that'll develop into that. We're just not quite there yet.
Okay. So, question from Willie, is the capital cost to implement a waste heat recovery system outweigh the benefit gained in the heat recovered? I can say that again if you like. Is the capital cost to implement a waste heat recovery system outweigh the benefit gained in heat recovered?
The answer to that would be, I don't think the economics work just on the energy produced. What works is the trucking really is the key element by reducing your trucking costs.
Yeah.
The energy would be a secondary benefit.
Yeah, no, I understand what you're saying.
Landfill fees, yeah. That kind of thing, for sure.
And this one is from Michael. What does the competition look like and i.e., who are your main competitors, and what is your competitive advantage? What does the standard system cost, and about scalability? And maybe we can get into a little more of that with Mike and stuff like that, and put him in contact with him. How many systems have you sold? What is your production capacity? And what kind of international markets are you looking at? Well, here's a few questions.
There's a lot.
Holy man.
So I'll give you an example. We have this in operation, this identical this container at a co-op grocery store on Vancouver Island. So it's in a little community called Ucluelet, which is south of Tofino. And we actually plugged this unit right in place of their cardboard compactor. We actually utilized the same hole in the wall that the cardboard went into. We cut a hole in our container, so their cardboard falls right into the shredder. And that eliminates about $3,500 a month in cardboard costs, because on the west coast of Vancouver Island, they used to truck that stuff back to the mainland. It's like 2.5 hours one way, right? So we've eliminated that cost. So when groceries go on the shelves, the cardboard comes back, and they used to be a cost for them. Now that's totally eliminated. But another element is they heat with propane on that. That's what the store water, the store heat is heated with propane. We've replaced the propane heat. We still have this still sitting there, but it doesn't turn on because we keep the water hot enough in the store that it doesn't ever turn on anymore. And there's so much excess heat now from the cardboard waste. We actually start putting in a big hydronic air heater. So now we're heating the entire warehouse. So we're just learning the benefits and plugging into an existing, I guess, cost recovery. So, I mean, just on their savings on trucking and everything, it was upwards of $5,000 a month. For a container like this, that's with everything in it, we're about 300,000 Canadian. We manufacture everything here in Canada. So we don't have to outsource. When Kim got into this, was interested in this, he's been interested in building a high-speed composter for years. And we were going to get into the compost business. And we built our first stainless steel composter to do that. And we had a PhD at the time that was up in Olds that talked to all the health and Health Canada compost. And they warned us and said, well, if you guys are going to get into compost, I wouldn't do that. We're going to start regulating that industry. And here's why. And we found out that compost material has 30% contaminants in it. It's filled with Salmonella, E. coli, it stinks. And we figured out real quick, we didn't want to haul food waste back to our plant in July and August on our trucks. We did that, right? We said, no, we don't want to do that. It just stinks. So we actually turned up the heat in our high-speed composters, and we turned them into high-speed dryers. And we just got efficient with it. And yes, we focus on using just that as energy source, but we through the guys at SAIT, through permaculturalists here in Alberta, we're actually feeding that dried feedstock as a fertilizer back to soil. So we put it less sparingly as opposed to like a compost material. And it's got the same benefits. We're actually feeding that to worms now. So it's not just an energy source, that is money sitting there in some form or another. We've had this tested for feedstock, like that we could use that as a feedstock for chickens, pigs, and we get 30 cents a pound for it if we want to. But we still haven't got to that point where we want to monetize it yet. So we look for the different opportunities in waste, whatever gives us the most bang for the buck and whatever is the most efficient way to deal with it is probably the way we're going to go to start. But as we develop different uses for the finished material, like there's no market for compost anywhere. The City of Calgary facility is a prime example of that. They make all this compost, but they have to sell the product at the end, and they can't sell it for what they wanted to. So another use for it would be different things like this. turning it into different feedstocks. But what we're doing efficiently is just prepping it into a shelf-stable product that can be trucked. Like we could take that same material 2-3 years down the road and deliver it to it. It's the same. It hasn't changed because we stopped the decomposition, we stopped the smell, we stopped and we sterilized it using the heat through our dryers. So it's a whole wide range of stuff that we're falling into. I invite you guys here to Calgary to come and see our plant, because we look for the waste, like even our CO2 from our stack. That point, we neutralize the pH in Kim's laundry water in his laundry. So we operate at high alkaline to get stains out of coveralls, rags, stuff like that. To bring the neutrality of the water back down to neutral, we have to add an acid. So instead of buying it, we actually mist water onto the CO2 from our gasifier, and we make our own carbonic acid in-house. So we neutralize our wastewater with that waste stream. And we said, okay, well, what else can we do with that waste stream? So beside us here in the container that's parked next to this one, we actually have a modular farm where we're harvesting and flowing the water that's acidic, but it also has trapped CO2. And we're off-gassing the CO2 into our modular farm, which is full of basil right now. And we're growing basil right next door in an industrial laundry in Calgary, which is just crazy. But that's what Kim does for a living, is just think crazy, right? So
Interesting. So the next question is, which kind of relates to this, I suppose. What type of energy does the dehydrator use, and how much? Like, you kind of answered that, but
So our largest
maybe you want to elaborate on it.
Our largest system is under 30% energy in, and our smallest unit, our 200 pound per day, is 40% energy in. And that system, the starting system, starts at $18,000, and that's a contained unit ready to go.
we have the kilowatt usage for each appliance right on our email stream. I like it simpler. Our smallest unit uses about $2 electricity a day, and our largest one uses about $9 a day in electricity for dehydration.
Okay. Lost my question here. Hang on. What is the capital cost? What is the cost of the capital cost for the equipment for digester alone versus the whole system?
So our smallest unit starts at 18,000. Our largest system is 60,000, and the in-between unit, this one here, is at
49,000.
49,000.
Okay, gives them an idea. Next question: how would this differ from incineration? I thought we would not. We could not incinerate in Alberta. He's probably speaking towards the your comment about the government, how they had to approve your burning
Sure. So
your boiler system.
This is a gasification system. So we're smoldering the material and burning the gas that's coming off. This system is certified under energy recovery. There is an incineration protocol in the province of Alberta, but we don't fall under that. Alberta environment certified us as energy recovery. So it's not incineration. It's a different process.
Okay. And we achieve higher temperatures by smoldering the materials and igniting the smolder, igniting the gas. So burning or incineration are 0 to 1400 degrees Fahrenheit. After that point, it becomes gasification or pyrolysis. We're operating temperature here in our gasification boiler. We're about 1800 degrees Fahrenheit in our boiler. So that's why you don't see any smoke leaving our chimney, because we combust it. So it's a clean, efficient way to deal with the emission.
Okay. Can it shred and can it shred and burn natural material, textiles, wool or cotton?
Yeah.
Yeah, I guess
We
so.
shred all Kim's laundry rags, and it gets to a point where they get too holy, get too thin, threadbare. So what do you do with this, right? We can throw it to the landfill. Guess what? It turns to methane in landfill. So we thought, well, let's turn it into a carbon neutral fuel source and combust it. Our dryer lint, right? So it's just a waste stream that we would have put in our dumpster, but now we don't have to. We can utilize it and heat our laundry water with it.
And Willie's just commenting that your heat exchanger there looks pretty small. It's very amazing. I was expecting he was expecting something bigger for that, the small little unit there, that plate exchanger you were showing us. Yeah.
So it's actually rated at 400,000 BTU.
That little.
So if anything, it's a little oversized.
Yeah, that is amazing, isn't it? We'll be talking about heat exchangers a little bit more next. See what we have here. Lots of questions. Is there the ability to buy an all-in-one system from you? And for example, all equipment plus building to house it all, or do some pieces, come from other suppliers? You sort of talked about that a little bit, but you can elaborate on that.
Everything you see here is we make from the structure to everything inside, and we call this the plug and play system. So it's delivered to our customers with the 1-point electrical connection, glycol in and out. Or you can a la carte. You can buy individual pieces. So it's completely customizable.
Next question is, Adam, what all can we heat with the end product? And he's laundry, building heat, pool water.
You can heat, it's a liquid, it's a glycol system. So you can go liquid to liquid or liquid to air. So you can heat air or a liquid.
Okay. What happens to the moisture from the dehydrator?
It's vented out. It's like a dryer vent at home. So it's wet vapor leaves the structure.
In this unit here, we have 1,000 pounds of wet food waste, which is 80% moisture. 800 pounds of water leaves our dryer vent every day on this unit. We're actually looking and we're condensing that back to a liquid. And we've tested feeding plants with it, but we think this will have more of an application down in the Caribbean countries where it's hard to get desalinized water, but they can use their organics that are online to feed their plants instead of getting water from a well or anything like that. So to rewater plants, to feed new plants like we're doing next door. Again, we're just looking at that waste stream even and saying, okay, let's condense that. What's the nutrient value in it? Can we use this as a fertilizing product? Can we use it as a variety of different things?
This is from Kevin. From my understanding, the city turns our household food waste into compost. Would it not make more financial sense to turn it into an energy source? Good question.
Yeah. Yes.
Right now, the city of Calgary's compost material, after it goes through the 160 cycle, gets trucked to the landfill. So we were trying to avoid that in the first place, but there's no market for it. You can't sell it. You can't give it away. Farmers won't use it because of the high levels of contamination. So what do you do with it? In every jurisdiction you go, there's a really interesting article in the Maritimes where they started a compost program like 2 decades ago. And they've got mountains of compost. They don't know what to do with it. Can't give it away. So yes, you're right. Turning all that material to an energy source is a no-brainer.
Okay, Jacques is just wondering where you're located. We can either leave that for Mike, or you can just tell us where you're at, I guess.
We're in southeast Calgary, right on the corner of Center Avenue and 28th Street.
Yeah, if they know where King's is, then they should be able to find you, right?
Yeah, well, the King's isn't open anymore, but
Oh, that.
we're a block away.
We're about 2 kilometers from the downtown core.
Yeah.
Anyway, does the machine produce any noise when it's running? Good question.
Well, the shredder does. You heard that. The boiler, no. And the dehydrator, there's a fan involved.
Do you want to hear it? We can turn it on here for you.
So you can hear it's in full operation right now. So what it's
Pretty
doing,
quiet.
it's dehydrating and size reducing. So we have a paddle mechanism that's agitating and desizing.
Oh, okay.
You can see it's not noisy.
We didn't get up for nothing here, Kim. So then there's bones, there's a little bit of everything in there if you can.
And the chicken bones disappear to a powder as well.
So we had to make this stuff handle contamination because we get it. And so everything in this unit is stainless steel. Every paddle, bolt, the tub, everything is stainless. Food waste is pretty acidic, so we tried other materials, but stainless is the way to go. And
Okay. I'll just see if I can find the next question here. I lost my space. Can you put I think you've answered this, but can you put compostable plastics? I guess he's getting back to the plastics, as the city of Calgary does not take it or compost it. Yeah.
so what we'll do with that product is compostable plastics is a vegetable based plastic container. So it actually is a biomass feedstock. So we typically don't have to dehydrate that. So we'll just shred that material, and that'll just go right into the fuel bin in the back, and we'll just feed it directly in our boiler, and it will combust.
So I bring my compost from home. We all have this little bin, and I put it in a compostable bag in this little bag, close it, and it just disintegrates, disappears.
Yeah, so that's quite incredible. So I guess what we'll do is we'll give Mike a few minutes here to let him know how he is involved in this, and you know, maybe they can reach out to him for more information on stuff as well, or arrange to come see or whatever. So Mike, are you there? Do you want to say
yeah, I'm here. Thanks, Mark. Appreciate that. Want to thank everybody for attending this webinar this evening, and also thank Bo for having us here. I am the owner of Clean Power Worldwide. We've been around the last 3 years promoting environmentally responsible solutions for buildings and facilities. I'd like to say that all of our products are Canadian, and Eco Growth is our newest member of our all Canadian lineup. With Eco Growth, we look to have a positive impact on your environment, and also on your have a positive impact on the environment by reducing your waste reduction. Sorry, I am an agent for Eco Growth. Sorry, I always say that wrong. And if you would like to have more information or like to have some numbers run on how we can help reduce your waste reduction, please feel free to reach out to me by phone call or email. Thank you.
Okay, so to answer the last question, yes, this webinar is being recorded, and it is available for on YouTube, and also it'll be available. You can link it to it on the Building Operators Association website, which is boacalgary.com. And then you can look for the link and you'll see all the presentations there. Or you can just go into YouTube and it's under Building Operators Association of Canada. And so we'll be putting it up there in the next few days. And then you can feel welcome to have a go through it again. I'm just going to check the questions here to see if I got them all.
I think we might have lost the other guys.
I guess the last question is just came in from Anna. So you can burn compostable plastic, but not regular plastic. So Glenn, do you want to answer that one? Is he still there?
I think they might have fell off there.
Whoops. Well, maybe you can answer that.
I just know a little bit about everything else. The plastic stuff I'm not really involved with. I'm sorry. It's a little bit new to me. But
well, sorry, Anna, I missed your question there, but
we get back to you on that one.
Yeah. And I'm sure we'll be talking about this a lot more, because there is, a lot of potential to do different things, right? And it'll be interesting to find out more about what they're going to do with that scrubber and their collaboration with SAIT. And so there's many different ways. I'm just about it. I can see all kinds of different potential from what I know as well. So there you go.
Yeah, the sky's the limit. There's a lot of potential definitely with this technology and waste reduction and so many different types of applications it can be used for.
Yeah, and then also probably with the carbon tax coming back, we'll all be learning a lot more about carbon offsets, all that stuff that's not well understood.
Credits for burning your garbage, not a bad thing.
Okay, well, Les, do you have anything to add, buddy?
I really don't. I guess I would have to say that this probably is the best and most attended meeting that we've had, and I think that it has a lot to do with the environmental responsibility for all of the inroads that we have with now as green is very important. LEED is also very important. This looks like it could be potential for LEED points as well. So I just want to take the time to thank you, Mark, for hosting this meeting, and same with Mike. Mike, thanks for bringing this to our attention. And as the guy said, if you get a hold of these guys, they will do a tour personally for you. So make use out of that. It looks like they got a good nugget there.
Definitely come down and check it out. There's a lot more than just garbage waste reduction there. You should check out their green room. They got some really interesting plants growing there.
Maybe get some
So I'm assuming then that they can get a hold of you, Mike, and then you can make whatever arrangements.
Yeah, please reach out to me. We can definitely set that up.
Okay. So do you want to give out your email address or anything?
It's cleanpowerworldwide@gmail.com.
Well, there you go. If we thank you very much, Mike.
Thanks,
it was
guys.
a good session.
How come he booted us out?
Oh, I didn't boot you
I think
out,
that was
buddy.
operator error on your guys' side.
So we do have one last question. And that was, what was it about? Oh, it was a question about the plastics, regular plastic versus compostable. And how come you can do something with one but not the other?
Because the emission, the compostable is a polylactic acid, PLA, which is a starch-based material. So it is inherently a plant-based material. So they'll both go through the system, no problem. But from an emission standpoint, we're certified for the PLA, but not the plastics.
Okay. So I'm assuming styrofoam fall into that same category then.
Yeah. I mean, it'll go through no problem, but again, it's an emission issue.
Yeah, so hopefully your little scrubber project with SATE then will reap some rewards, or who knows, right?
Yeah.
There might be somebody that's listening to this that'll have a solution for you. Who knows?
Well, we actually do have a solution. We have another technology, oil and gas system, but it requires an afterburner with, now you need propane and a whole other system. So it's doable, but I mean, this is a micro, it's an inexpensive system, easy to operate. Anybody can operate this, literally anybody.
Okay.
So it's simple. Keep it simple, stupid.
Yeah, no, well, that's fair enough. Well, I'll just check see if there's one last questions here. I think I got them all. Yeah, they're all saying thank you. So it's a beautiful thing.
Well, thank you for having us.
Thank you for entertaining us.
Thanks for having
Yeah,
us.
and great audience participation. We always love that. So maybe we can put together an update once you get your SATE thing going there, or whatever. You'll be able to talk about some more stuff as things progress.
Yeah, 100%.
Come and see us.
All righty. Well, thank you very much, guys. Appreciate
Thank you,
it.
everyone.
Stay
Thank
safe
you.
and
Stay warm.
stay warm.
Stay warm.
Yeah, no doubt. Just snuggle up to that wet garbage there. You'll be fine.
Perfect.
And
Thanks, everybody.
Just so you know, we were joking before, but Muffin Monster, Channel Monster. I don't know if have you ever seen what I'm talking about?
I've never seen it, but I can imagine what a muffin is. So
Well, exactly. It's the real thing, and guess what? So that's a very common thing used in wastewater, and they'll grind anything. So you can, and pulp mills use it for grinding up wood to make pulp. So anyway, there you go. So it's just a different version of the same thing. That's pretty cool.
yeah, we
All
try
right,
and keep
guys.
it. Yeah, keep it the same.
Okay.
Yeah.
Guys.
All right.
Awesome. All right.
Night. Okay.
Take care, everyone.
Thanks, Mike. I guess we're out of here. We're out of time and
Thanks,
out of
Mark.
bullets.
Thanks, Les. Good seeing you guys. Take care.
Bye for now.
Bye.
Okay. Bye-bye.